Hey guys, here we go. We've got multiplying and dividing algebraic fractions, section C. Kind of like section B, it starts off pretty straightforward. We have the two idea, you multiply two fractions together, the numerators get multiplied together, the denominators. So they want to make sure you know what's going on. So in the first example, we have 3 over m times m over 6, which can be seen as 3 times m over m times 6. Now that we have it set up like that, we see that the m's cancel. And that gives me 3 over 6, which as you all know is 1/2. So the beginning starts out pretty straightforward. That's the first one. For B, same idea. We got to visualize this as 3 over m times m squared over 1. So I have 3m times m, because some people don't like to write it as m squared. M times 1. M cancels with m. I'm left with 3m. Now, you may see it this way as well. Whichever way works for you, I'm totally cool with that. You know that you can cancel the 2 and the m, so you have 3m. I'm just doing it this way to make sure everybody sees what's happening. So, that's multiplication. Division, as you know, it comes back to multiplying by the reciprocal. So if I have a over b divided by c over d, it becomes a over b times d over c. Just check, make sure. Perfect. So if I have 4 over n divided by 2 over n squared, flip. 4 over n times n squared over 2. Quick way, no, I won't do it yet, equal to 4n squared over 2n. 2 cancels with n. I know some of you don't like this. 4 cancels with 2 and gives me 2 over 1. So I'm left with 2n. So, the next one, whole numbers tend to get people going. So I've got 3 over a divided by, think of it as 2 over 1. So that becomes 3 over a times 1/2. So 3 times 1 over 2 times 2, 3/4. And multiplication, division, does it get any harder than that? Yes, it does. So, pay attention when doing this. This is going to seem kind of silly. Look at what you have to see if you can cancel or make your life a little easier before you get going. So, I have y squared minus y minus 2, times, I'm going to do one step right here. I've got some factoring I can do here. It's going to be multiplied by 3, y minus 2, because 3y minus 6 is equal to 2, or is it equal to 3, y minus 2. In the bottom, same idea. I have 4y minus 4. That's going to become 4y minus 1. Now that I've done that, I look back at this and go, oh, hey, I could have done some work up here. This could have been factored. So instead of writing it like that, can I move just that? No, the whole thing goes. So I'm going to erase that so that we have y minus 1. Why am I doing all that? That's kind of funny since we're using y. y minus 1 times 3 times y minus 2. That's everything on top. then I get y minus 2 times 4 times y minus 1. Y minus 2, y minus 2, y minus 1, y minus 1. I'm left with 3y over 4. It's a nice little simplification. The next one, because it's division, first thing, I have 5m minus 4. Now, if you can't read the question that's up here, remember, it's example 11 in the book. So I'm doing the factoring right away. And that's all over 4. I'm going to flip and simplify at the same time. I can't do anything with the 3, but I can factor out the 2, and I'm left with m minus 4. Now, I don't have to all of a sudden take this step down here to cancel. This multiplication is enough to tell me I can do that here. So, that, all of our variables are gone. We're now left with 5 times 3, 15 over 8. Pretty sweet simplification. And does it get harder in this section? Nope. Perfect. That's it for section C.